Alright, so number one, we say if n is a natural number and 9 divides n, then 3 divides n. Okay, so we have this 9 divides n, then 3 divides n. So how do we know that? Well, since 9 is equal to 3 times 3, 3 will divide 9. And so since 3 is a factor of 9, it will also divide this number as well. So what does that look like? What does this mean? So let me just pick a number. Let's just say 18, because I know 18 is divisible by 9. So since 18, or 9 divides n, so I'm saying that that's n, okay? Since 9 will divide 18, and we know that 3 is a factor of 9, then we can also say that 18 is also divisible by 3, because it's just part of 9, it's a smaller factor, which would give us 6. Okay, so you could divide by 3 again, because 3 times 3 is 9. So if I divide, I can also say 6 is divisible by 3, which gives us 2. So it's like dividing by 3 twice when we divide by 9. So if the smaller number is a factor of the first divisor, then it will also divide that number. That's kind of what this problem is saying. So this is going to be a true statement. Now we want to find all the factors of 147. Okay, so this is not one of those easy divisible numbers. So we want to use those divisibility rules. So I can look at this and see it doesn't end with a 2. So it's not even. So I know I can't divide by 2. But I want to see if I can divide by 3. So the divisibility rule for 3 says add up the digits. 1 plus 4 plus 7. That will give us 12. And so since 12 is divisible by 3, this number should be divisible by 3. So we're going to divide by 3. 3 will go into 14. 4 times. 3 times 4 is 12. Subtract 12. You'll get 2, bring down to 7. So 27. 3 will go into 27 9 times. Okay. And 49 is 7 times 7. Okay, so all the factors of 147. So what I do, and the book doesn't show this method, I'll break it down to prime factors first. Find that to be one of the easiest ways to list all the factors. When they say list all the factors, I'm going to be using all possible combinations of 3 times 7 times 7. I'm going to try to go in increasing order. Okay. So all the factors of 147 would be first 1 times itself. So I'm going to write 1 and 147. Okay. Now I know 3 is a factor of this number. So if I use the number 3, because that's the next smallest thing I can make. So I'm going to write 3. So if I use 3, I have to use all these numbers. So if I use 3 to make one number, then 7 times 7 is going to give me 49. It's going to make my other number. That's what we started with. 3 times 49. So now the next biggest number I can use is 7. So I'm going to cover up this. So if I use 7 as one of my factors, then I need to use the other 2, whatever I didn't use. 3 times 7, that gives us 21. So 7 times 21. And I think that's going to be it, because I can't make any other numbers. We've done 3 times 7 to get 21. And that's the same thing. If I did this 3 and that 7, we've done 7 times 7 is 49. So if you can break it down into prime factorization and just use every combination that you can get. I've used the 1 in itself, the single 3, the single 7, and whatever I had left, and then that's all we can come up with. So this would be all the factors of 147. 1, 3, 7, 21, 49, and 147.